Good morning, my YouTube viewers. Crystal here. I wanted to make a video for you this morning on the Kaggle website. And what I wanted to talk about was their competition question, real or not real, natural language processing with disaster tweets. I wanted to show you my latest entry. I got a 78.36%, which is the highest entry that I ever have had. And so I wanted to make a video on that and show that to you. And what I did was I used the pipeline. So what we're going to do is we're going to actually go into the program that I wrote where I had the pipeline, and you can see that I submitted this successfully. And what I'm going to do is I'm going to share this. So I'm making this public, so anybody can look at my program if they want to look at my program. And now what I'm going to do is I'm going to do code review. So the first thing we'll do is we'll talk about the problem statement. Twitter has become an important communication channel in times of emergency. The ubiquitousness of smartphones enables people to announce an emergency they're observing in real time. Because of this, more agencies are interested in programmatically monitoring Twitter, i.e. disaster relief organizations and news agencies. But it is not always clear whether a person's words are actually announcing a disaster. Take this example. The author explicitly uses the word ablaze, but means it metaphorically. This is clear to a human being right away, especially with the visual aid, but it's less clear to a machine. In this competition, you're challenged to build a machine learning model that predicts tweets about real disasters and which ones aren't. You'll have access to a data set of 10,000 tweets that were hand classified. If this is your first time working on an NLP program, we created a quick tutorial to get you up and running. Disclaimer: the data set for this competition contains techniques that may be considered profane, vulgar, or offensive. This data set was created by the company here and originally shared our data website. So what's nice about this data set is it's not too big. It only has like a total of 10,000 tweets. The data set with previously, i.e. the data sets in the analytic website were, it was a lot. I think it was like 500,000 tweets, and because it was so many tweets, my computer kept crashing. So since this was a small data set, I was able to do it without crashing my computer. So that's positive. So the first thing we do is we import our libraries. And then what we do is we load our train test and sample file. And we want to do is we want to impute any null values. So we have imputed all the null values, and I just decided to replace any null value with unknown. And the reason why is because the null values were in keyword and location. And because the null values were in keyword and location, I wasn't really using those columns to predict anyway. So I just said rather than using the mean or the most frequent, I decided, well, that's not really good to use the mean or the most frequent, because then people are going to think it's actually in that city, and I think it's better to just say unknown. So that's another tactic that I've used, even though I didn't actually use the keyword and the location to analyze the data. So we did another check to see if we had any null values, and after we replaced all null values with unknown, we didn't have any more null values. So now we're going to compare the tweets in the train and the test file. So you can see that there's more tweets in the train file than there are the test file. So we're going to identify the percentage of disaster tweets. So you had 4342 were not disaster tweets, and 3271 were disaster tweets. So now we're going to identify the percentages of disaster tweets. So 57.03 were not disaster tweets, and 42.97 were disaster tweets. And then what we did was we did a group by that showed you basically the same thing previously, that 42.97% of the tweets were disaster tweets. Now I want to show you the little chart so you can see the representation of the non-disaster tweets versus the disaster tweets. Now what I've done is just add a little extra bells and whistles. We put the tweets on a counter. And so 4342 were not disaster tweets, and 3271 were disaster tweets. Now what we're going to do is we're going to pre-process the data. So when we pre-process the data, we put we installed the HTML parser, and we created an extra column called tidy text. And this column called tidy text is going to be where all of the data manipulation occurs. So what we wanted to do is we wanted to count the words that we were going to pre-process. So there were 113,654 words in the train data set and 48,876 words in the test data set. So those were the words that we're going to pre-process. So now what we've done is we've identified a function to remove the pattern. So the first thing we want to do is we want to remove the Twitter handles because all of those were anonymized anyway. And the next thing we want to do is we want to turn all the tweets into lowercase. And after we've done that, we had an apostrophe dictionary. Taking all of the apostrophes and put in the real words. And then we have a function called lookup dictionary. And what the dictionary does is it replaces the words with the apostrophes with the full words. And I have a short dictionary. And so what we do is we replace all the short words with the real words. We have an emoticon dictionary. And we replace all the emoticons with the real words. And this is a dictionary that I made, and I wasn't really sure what to do, but I wanted to make sure that it was a disaster. So I made my own dictionary, and I added the word disaster to all of these words to make sure it was. And then, so if any of those words appeared, then the word disaster was added to it, just to make doubly sure that it was actually a disaster. So we removed special characters. And then what we did was we removed rare words. And so I had to look on the Stack Overflow, and found coding so we can remove the rare words from the train file and the test file. And I had to experiment with that as well. So then what we did was we removed any words with a length of 2 or less. And so now what we did was we wanted to tokenize the tidy tweet column. So the next thing we're going to do is we're going to stem and remove stop words. So that we've done, we stemmed and we've removed all the stop words. So we're doing is we're going to count the words to analyze. So in the train file, we have 80,811 words, and in the test file, we have 34,816. So that means that we have reduced the number of words that you have to analyze, which is a good thing. Now we just put all the words on a word cloud just to give you an idea of the words that were on the word cloud. So all the words, and then you had no words. So now what we're going to do is we're going to do something with the hashtags. So we're going to extract the hashtags from the normal tweets, extract the hashtags from the negative tweets, and we're going to unnest the tweet. So now what we want to do is we want to define the X, Y, and X test. So Y is train target, X is train tidy text, and X test is test tidy text. So we're going to split the train set out for training and testing. Now what we've done is we've created a pipeline. That's something that I was experimenting with yesterday. So we have created this pipeline. So model equals pipeline. We put it on the count vectorizer, and then we put it TF-IDF transformer. So the count vectorizer and the TF-IDF transformer do the same thing that the TF-IDF vectorizer do. The TF-IDF vectorizer is new. So in theory, we could have just used the TF-IDF vectorizer, but I wanted to experiment with the count vectorizer and the TF-IDF transformer, so I used those. And then the CLF is linear SVC with a class weight of balanced, and C is 0.5. And so your model fit is X train, Y train. So it shows you what your pipeline steps are. So now what we do is we put it on an accurate classification report or an accuracy report. So you can see the accuracy is 77.03%. And you can see the classification report as well. So we put the YPRED on a data frame so you can compare values against the predicted values. And now what we do is we predict on the X test, and then we put in data and we submit that, and then we put that into a CSV file which we submitted to Kaggle, and we got a rating of 78.36%, which is the highest percentage I have achieved so far. So that's it for this presentation. If you like my video, please like, subscribe, and share. If you like the work I do and want to make a donation, I've got my email address to my PayPal account in the description below. The reason why is I don't have enough subscribers, so I can't monetize, so I have to ask for donations to make money on this account. And thank you so much for watching this video, and I look forward to making the next video for you.